Hello and welcome to another video notes. This is for lesson 4.11. We are on unit 4, lesson 11. That's what that means. So go ahead and title your notebook. We're going to take some notes. I have to talk about this, and then I have 1, 2, 3, 4, 5 examples to get through. So I could probably make this pretty short. There's two types of concavity that we talk about with parabolas. We have concave up, which is this guy, and we have concave down. Now I'm going to write the word concave. What you can do is sketch in a concave up parabola and a concave down parabola. Now, what does this mean besides that all of these numbers are that it decreases and then increases, versus if it's concave down, it increases and then decreases. So what does that mean? It means that the equation, every graph has an equation that goes with it. The equation that goes with this is either positive or negative. We talked about in standard form, quadratics have this standard form that looks like this. Well, A can be positive or negative. A value can be positive or negative. When I look at a quadratic, the first thing I look for actually is the A value, if it's concave up or concave down. That's the first thing I look for. So, for example, this parabola has a positive leading coefficient. So its graph will be y equals positive ax squared plus bx plus c. Whereas this graph over here is concave down. So its graph is going to start the leading coefficient, which is the number A. This is the leading coefficient. The word is coefficient. In this case, the one I circled in purple, its leading coefficient is negative. So it's concave down. So whenever you just see the equation, start imagining a picture. If the leading coefficient is positive, you know it's concave up. If it's negative, you know it's concave down. All right, let's go through the examples. The first skill that we are going to practice is graphing parabolas from factored form. That means I'm going to give you the factored form, and then you have to just sketch a graph. There is an important moment where you have to decide, do I sketch the graph or do I plot it perfectly with all the points? And I'm going to leave you to figure that out, and I will help you figure that out. Let me just insert a graph onto here. So I will be right back. Okay, I'm back. We're going to sketch this parabola. How this works is if you are given a graph, so you're given this graph right here. Oops, did not mean to mark that. Oh my goodness. And we need to graph it. The first thing I look for is the leading coefficient. So go look. The leading coefficient is positive because there's no symbol right here. If there was a negative, we would know it's negative. If there's no symbol, we can default to positive. So we already know our graph is going to be concave up. The only other information we have so far is that we can figure out where the zeros are, or the solutions. As a reminder, solutions are where the graph touches the y-axis. So that's when the the graph touches the x-axis. And that's where the y value is 0. So we can use our zero product property, CPP. We have x plus 2 is equal to 0. X minus 4 is equal to 0. So we are going to find the solutions. That means x equals negative 2 means that the y value is 0 and the x value is negative 2. So I've plotted my solutions. These are solutions. You see how they're on the graph? The only other way that you know how to do this right now is the vertex has to be in the middle of the 2 and the 4 for the axis of symmetry. So -2, 1, 2, 3, 4, 5. Okay, so there's 5 spaces in between this graph. 1, 2, 3, 4, 5. That means 1, 2. The axis of symmetry has to be exactly in between it. And then from there, just pick a point on the axis of symmetry to act as your vertex. And then just sketch in a parabola. There's more information on how you can exactly find the vertex, but we're not going to do that yet. So the only way you know how to sketch in this parabola is you know it's concave up or down, and you know where the zeros are. Okay, again, for example 2, already I know that it's going to be concave down because this guy, concave down. So my graph is going to go this way, concave down. Now, where do I put my solutions? Well, I set y equals to 0, and then I can solve for x. Watch, there's this negative right here. I am going to divide both sides by -1. Because it's an equation, I can divide both sides by -1. So if you're ever wondering where that negative goes, or if there's a number in the front, you just divide both sides by that number. Okay, x plus 1 is equal to 0. What I'm doing here is I'm solving for the solutions. Okay. And all I know is that I have the solutions and it's concave down. The vertex needs to be on the line of symmetry. So the line of symmetry is x is equal to 0. So I know that my vertex is somewhere on this line of symmetry. And it's because the vertex is going to be in between the two zeros. There's the same amount of distance to the left of the axis of symmetry as to the right of the axis of symmetry. So it's going to be right down the middle. So this was my sketch. It's the best I can do with the information that I have so far. Let's do this once more. Example 3 looks kind of weird. All I know so far is that it's concave down, and I'm going to set my y value equal to 0 so that I can find my solutions. So this leading coefficient, I'm dividing by the leading coefficient. And I'm going to get this. From here, the only reason why I put this is because it has a weird example. You still need to use zero product property, and you need to solve for your y values. So now I have my solutions. So all I know is that it has zeros at x is equal to 0 and x is equal to 5. And then it's concave down. Its axis of symmetry, 1, 2, 3, 4, is somewhere at the 2.5 mark. Because between 0 and 5, the axis of symmetry is going to be in the middle. And the only other thing I know is that it's concave down. So I'm just going to, whoa, that's a good one. There's my parabola. It's hard to draw on these things, okay? So make your parabola look better than mine, please. That's all I know. It's just a sketch. It's not very exact. There is a way to calculate this exact vertex. We're not going to talk about it in this video, but soon, I think. 2 more examples. How are we doing on time? 9 minutes. All right, I think I can do this in 2 minutes. Given a graph, here's the second skill you're learning in this video. Given a graph, write a potential equation. So now we're going to go backwards. So your answer for these types of problems where you're given a graph and you need to write an equation, it's going to be in this form. It's going to be y equals, this is either going to be positive or negative, and then you can put the zeros in, the factors. So usually your factor is like x minus something or x plus something, but in this case it's just like I'm just writing the word factor. So your answer, I'm really big on like, if you're given the directions, what is the answer? The answer is going to be plus or minus, and it's going to have two factors. From there, you can expand into something that looks like, you can use box method, and then you'll end up getting ax squared plus bx plus c, or some form of this. I'll show you what I mean. For example, example 4, all I know is that it's concave up. So my leading coefficient must be positive. That's a big hint for me. My zeros are at x is equal to 1 and x is equal to positive 3. Positive 1 and positive 3. Watch how I turn them into factors. Turn zeros into factors. Watch how I do this. Okay, so I have x plus 1, right? I need to set it equal to 0. So I'm going to subtract 1 on both sides. Ah, look at that. Factor. It's good, right? I'm clever. Factors have parentheses, so I put parentheses around them. So your answer is going to be something, your equation, we know it's positive, and all you have to do is put the factors right back next to each other. So now you have this equation, and then that is a potential equation for this graph. The other way, the additional way to do this is to expand. And in your scratch work on your side, scratch, you do a box method of x minus 1 and x minus 3. And what you do when you do your box method and you add up everything on the inside, you end up getting x squared minus 4x plus 3. And I'm just going to put a big plus there so I know it's going to be a concave up parabola. So both of these answers are correct. This answer for me, when I see it's in factored form, I know you know the material really fast. This one, you're going to make me do math to check your work, and let's just start with the factored form. Okay, let's do one more example. This last example, it's the same thing. We're going to take this picture, this graph, and we're going to write an equation. What do I know about this already? I'm scanning. I already know it's concave down. So that means the leading coefficient is going to be negative. Now I need to find the roots. Roots, zeros, solutions, they're all the same thing, and I use them interchangeably. Sorry and not sorry. So watch how I do this. I go find the roots. X is equal to positive 3, and x is equal to positive 7. And what I do is I turn them into factors. Turn into factors. To do that, I subtract 3 on both sides. I do not combine these terms because they're not like terms. And now I just put them, I literally just take my factors and I just put them next to each other. So x minus 3, okay, x minus 7, and put them next to each other. So y, whoa, y, oh no, y is equal to negative x minus 3 and x minus 7. Ta-da! This is in factored form. Factored form. You can guess because it's in factors. The other way to do this is if you expand this, or expand. Use your scratch work to multiply. Some of you are starting to do this in your head, which is like, okay, but you might make a mistake. Oh, watch this. So I have a negative, and I put parentheses around here. So when you do this box method, you end up getting this. Let me double check. Yeah, okay. Now, when you expand, if you do not have your parentheses, it is not correct. If you want to take your parentheses off, you need to distribute this negative to all 3 terms. Okay, so this is also correct. This is also correct up here. You see how there are many correct answers? That's good. Okay, I've talked enough. Go ahead and summarize. To recap this video, there was a really big important play between taking an equation and then sketching a graph, and then doing the reverse, where I give you the graph and you have to give me a potential equation. Make sure you write in your summary about concave up and concave down, and what does that mean for the leading coefficient. I'll leave you with this: positive leading coefficient and negative leading coefficient. Bye.